Hi, everybody, and thank you for joining us today for our Insulation Intel webinar, Mineral Wool Product Selection Criteria from Specification to Installation. My name is Kim Melton, and I'm going to be the moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. First and foremost is that we are working from home. So if we run into any technical difficulties or anything like that, we'll take 5 minutes to try to address those technical difficulties. If we can't address it in 5 minutes and it's disruptive to the presentation, we will we'll cancel the presentation for today, and we will either send out a new invite for a new date, or we will record the presentation and send you the recording so that you can watch it at your leisure on demand. So if you have any questions today during the presentation, please use the Q&A section to submit that. And you should see that to the right side of your screen. Now, if you don't see a Q&A on the right of your screen, if you hover over the center of your screen with your mouse, you'll see a series of circular icons come across the bottom. The second from the right is an ellipsis, and if you click on that, it'll open up a menu where you can select Q&A, and that will open the dialog box that you can use to submit questions during the presentation. At the end, we'll answer those questions with Scott and Natalia, our presenters today. Another thing I'd like to go over is that this webinar is for educational purposes only, and it shouldn't be used as a substitute for professional engineering design, consultation, or documentation that might be required by building codes, contracts, or applicable laws. So if you have any questions about this after the webinar, you can refer to our specific application guidelines and instructions located in the product sections of our website. Additionally, we're going to follow today's presentation with a survey. Now, this is your opportunity to provide us with feedback on how we've done today. You can ask any additional questions you may have about the topic of the webinar, or even suggest future topics for future webinars. Now, this is part of how we deliver the JAM experience to you. And if you look in the bottom corner of your screen, the left corner there, you'll see people, passion, perform, and protect. And those are the core values here at JM. And we use webinars like this one to make sure that we're delivering that to you as our customers. But it's not just a one-way street. So your feedback that you provide us in the survey is a critical component to ensuring that we can accomplish our goals and make sure that we're delivering the best experience to you. Also, we're frequently asked whether or not we send out these presentations. While we won't send out the presentation itself, we will post a recording of it online, and this ensures that you can watch it within its full context and watch it at your leisure. So with that, I'm going to turn it over to our presenters today, Natalia Maximova and Scott Sinclair, and I'm going to allow them to introduce themselves. So Natalia, if you could go ahead and kick us off, that would be great.
Hello, everybody. My name is Natalia Maximova. I am a senior product engineer at Johns Manville. I've been with the company for a year and a half, working with mechanical industrial insulation, and my background is in chemical engineering.
Good morning and good afternoon, everyone. My name is Scott Sinclair. I am the National Specification Manager for Johns Manville Industrial. I've been with JM for just over a year, but I've been working in the field of industrial insulation for about 17 years. And prior to that, my background is actually in electrical engineering. So with the introductions covered, we'll take a quick look at the information we'd like to try and address with you today. We're going to talk a little bit about insulation selection criteria and the things that you might need to consider when trying to identify what might be the best material to use for your particular project or application. Focus quite a bit on understanding water repellency and how that relates to the characteristics and performance capabilities of different insulation materials. We'll compare some product benefits within the mineral wool product family, and then we'll also do a little bit of a discussion about things you can do or things you can look at to try and take mineral wool to the next level of performance, maybe using it in some applications where you previously would not have considered using it. So with that covered, we'll go ahead and jump in and start the discussion talking a little bit about insulation selection criteria. At the very top level, when you're just starting your design focus and trying to take a look at the project or applications that need to be insulated, you're going to obviously have a variety of different reasons why you may need to look at insulating different sections or elements of the project. One of the dominant in the industrial arena is for process control or heat conservation. So basically trying to keep hot things hot or cold things cold. Depending on the geography of where the project may be located, you might need to consider freeze protection to keep the fluids or materials within the piping and equipment from solidifying and freezing. More and more today, acoustics or noise control is becoming a very important factor in designing industrial facilities. So you would need to look at the acoustic properties of the different materials if that is a key element of the project you're working on. Fire protection can also be a very important element and brings in a whole very specific realm of considerations that you might need to look at. Personnel protection is one that we see very frequently, especially in these types of applications, making sure that the people working in these facilities have a safe working environment. And that can be critical on both the hot as well as the cold or cryogenic side. And then we also see a lot of focus these days on reducing energy costs, linking back into process control and trying to prevent loss of heat or gain of heat in cold applications, trying to reduce the consumption of natural resources or energy, reducing emissions, and basically looking at things like your return on investment. One of the areas where you might need to start your focus when you're trying to determine what the best material is looking at the process temperatures of the piping or equipment that you're going to be insulating and making sure that you are selecting a material that is rated to handle the temperatures that will be involved. On this slide, you can see a pretty straightforward representation of most of the different products that you might encounter in an industrial insulation environment, and the range of temperatures over which each is rated, with materials being rated from down around absolute zero at minus 450 degrees Fahrenheit up to 1800 degrees Fahrenheit for your very high temperature processes. There are other very specific insulation materials available, typically known as refractory materials, would be your super high temperature above 1800 degrees, but these are your typical process temperatures that you'll encounter. So it is important to take a look at these and understand what the capabilities or the ratings are for each of the materials as you start your selection process. The products that are outlined in that white box at the top are the materials that Johns Manville manufactures and supplies. So you can see we do produce a wide number of the options that are available. Once you've gotten through identifying the materials that might be able to handle the process temperatures that you'd be dealing with, then there's quite a number of other parameters and factors that you would need to consider in trying to identify which material you want to work with. Things ranging from thickness profile. So if you know you have space limitations on the amount of insulation that you can apply to piping or equipment, that might be a very critical parameter to consider. We touched a little bit on acoustics at the very beginning, whether or not you need to have a material that does contribute to acoustic or noise control, as well as providing thermal insulation capabilities. Depending on where the piping or equipment to be insulated is located, if it's within reach of an area where it might be subjected to mechanical damage, people walking on pipes or backing trucks or vehicles into it, compressive strength might be a very important characteristic to consider. Hydrophobicity, the capability of the insulation material to not absorb water, is becoming a very important factor these days as people are looking at corrosion under insulation and the ability of insulation materials to help slow down the rate of corrosion under insulation. In many projects, cost is a key element, so you'll need to keep that in account. Combustibility can be very important in a lot of the industrial facilities, and they're not only just the combustibility of the material, but also the flame spread and smoke generation rating of the product. So you'll need to look at that. I mentioned corrosion under insulation a second ago. That is becoming a very important topic these days. So looking at your insulation materials, determining if they do indeed offer any capability in terms of including active corrosion inhibiting compounds in the formulation of the insulation. and therefore providing the best available protection against CUI. And then also looking at things like the weight and thickness profile, and again, seeing if that's an important factor in your decision-making process. So if you've gone through this first level of selection and come down to deciding that mineral wool is the best product that you want to work with, within the mineral wool product family, there is also a wide variety or array of different configurations of the material available. So then you'll need to, again, go through some of these relevant criteria and use these to then try and determine, okay, what is the appropriate format or configuration of the mineral wool insulation material that I need to use in the different areas of this project. And within a specific project, you may have different areas of it that would require a different solution depending on if they do or don't need thermal, acoustic, or both capabilities, and if there are different requirements for combustibility or water repellency in different areas of the facility. So you may have to do several iterations of looking at the priority of the different capabilities before you come down to the specific answer of what's the most important for you. As we mentioned earlier, we're seeing a lot of focus these days on water repellency. So looking at your mineral wool product and looking at the fact that within the JM mineral wool product family, our entire industrial family is now water repellent. That was effective about a month ago. Mineral wool typically is going to be your least cost solution. So that can be definitely one factor in its favor as part of your selection process. When we start talking about the configurations of the mineral wool insulation, one of the configurations is what is called V-groove, and that offers some very specific benefits related to material storage and transportation, and we'll talk about that in more detail in a few slides. And then mineral wool is typically accepted as one of the industrial insulation materials offering the best noise control or acoustic performance. So as an insulation material for industrial applications, it definitely has quite a few factors that would help you decide that might be the best solution for what you're trying to do. So let's take a look at the water repellent mineral wool family. As many of you may know, our mineral wool product line is known as Manville 1200. And within that family, as I mentioned, we do have quite a variety of different configurations of the material available. And as I also mentioned, the entire family is water repellent or water resistant, as indicated by the little water drop logo that you see on the slide. The MANDREL wound product, also known as molded pipe insulation, is prefabricated in the pipe format structure for small diameters. It will be a single cut, one longitudinal cut, and hinged on the opposing side. For larger pipe size applications, it will be either two clamshells or possibly quad pieces to cover the circumference. Another option for pipe insulation and possibly tank and vessel is looking at the V-groove offering within the mineral wool family. And within the V-groove family, there are three different formats available. The main format or primary format is the one on the top right there called the field formed. And so that is basically taking mineral wool board product of the appropriate thickness. We cut precision grooves in the insulation such that when it is wrapped around the pipe, all those grooves close perfectly and you don't have any gapping or air spacing in there. There is an adhesive sprayed on the walls of the groove so that when you wrap this around the pipe, it does hold its shape as similar to the shape of the molded or MANDREL wound product. There's also a pre-formed version of that's offered where we actually take those V-groove pieces and pre-shape them into the round format for you instead of shipping them flat. And then there's the precision cut version, which is the same as the field form version, only there is no adhesive in the grooves. Moving on in the product portfolio, we have some board and Batt products. So our Mineral Wool 1200 industrial board product, which from a water repellency perspective is covered by the British standard EN 1609, as is the flexible Batt configuration. And then we also have some products in the wrap and blanket format. So we have our Lamella tank wrap, which is basically a material manufactured from strips of board material glued to or adhered to a backing, as well as our pipe and tank, which is a material that is fabricated in that format rather than being segments that are glued together to a backing. And then also the metal mesh blanket, which is the flexible mineral wool with a chicken wire-like wire mesh on one side that can be conformed around different shapes, and it will hold that shape once it is formed. So you can see there is quite a wide variety of different configurations available. And with that said, I will hand things over to Natalia and let her talk to you about water repellency testing.
Excellent. Thank you, Scott. So as Scott mentioned, all of our mineral wool portfolio now, both pipe as well as the product as well as the Batt and blanket and board forms, are water repellent. So why did we do that? Well, as we've already touched on, the corrosion under insulation is one of the concerns. And in order for corrosion to occur, you need to have three elements. You need something to corrode, such as unprotected metal. You need to have oxygen, and also water or corrosive chemicals need to be present. So by introducing water repellency, what we are trying to do here, we're trying to attack this one, we're trying to attack the water and corrosive chemicals and prevent them from getting into the system. And in order to talk about water repellency, we obviously need to have some testing and be able to show, whether product is water repellent or not. So looking at the test methods, within Canada and the United States, we typically focus on ASTM. That's where our material standards are coming from, as well as many of the test methods. However, within ASTM, we don't have the test method currently, at least, that touches on kind of surface water repellent properties of the product. We have test methods that talk about the water vapor sorption, as well as various kind of submersive and wicking tests, but nothing related to the surface treatment, if you will. And so that's why one of the things that has been happening in the last few years is introduction of British standards. And this is what we'll talk about right now. So the way the British standards work, there's two of them. This one, 13472, is for the pipe geometry. And there's a very similar test method for the flat geometry. That's what we would use for the blanket and board products. And the way it works is that based on the pipe that we're testing, it will be dependent on the OD of the pipe. We will determine the length of the section, and then the section will be submerged into water to only 20 millimeters in this case. And then we will determine the weight gain. And then in the end, what we're going to do, we're going to report the numbers as normalized per square meter of the surface area. So currently, all of the mineral wool within Johns Manville portfolio tests at 0.35 kilograms per meter square. So the question may be, what would non-water repellent mineral wool do if we were to do this testing? Well, actually, the numbers are totally meaningless because, as some of you know, non-water repellent mineral wool actually absorbs as a sponge. So the entire thickness of insulation absorbs a huge amount of water. So the numbers really don't represent the reality in this case. So the next test method is for the flat geometry. very similar in principle, except for the surface area is a little bit easier to measure because we're talking about 20 by 20 centimeter square. The test is done the same way and reported in kilograms per meter square as well. With this testing, it is important to note that the test can also be done on the material as is, but we also can determine water repellency on the heat-treated samples. So we can determine if water repellency stays with the product after exposure to temperature. So that can be done as well. And with this, let me hand it back over to Scott for the next section.
All right, thank you very much, Natalia, and a wonderful discussion about water repellency testing. So let's take a look at one of the other critical characteristics that we talked about earlier on with regard to the mineral wool products and their ability to provide acoustic control or noise reduction. Typically within the industrial market arena, we are seeing an international standard, ISO 15665, being adopted as the most common standard for looking at the acoustic performance of industrial insulation systems. And it is important to note that the way this standard and the test methods that it outlines are defined, it is a standard relevant to the entire acoustic system, not just the insulation material itself. So if the system consists of a combination of an acoustic insulation material, mass-loaded vinyl, and jacketing of some kind, either metallic or non-metallic jacketing, the entire system, as configured, must be tested. As I mentioned, the standard does define not only the test methods to be utilized in determining the performance of the system, but then it also continues to create 3 classifications for different levels of noise reduction. And those are, as you see here, the Class A, B, and C, with Class A being the lowest level of noise reduction and Class C being the highest. There is also an additional Class D that is out in the industry that was created by Shell Corporation and is defined in their acoustic DEP, and that is even more stringent than the Class C. And so you do have 4 different options available. Within those classifications, the performance levels are also then broken down by pipe size ranges. The pipe size is directly correlated, obviously, to the amount of surface area on the pipe, and the amount of surface area can and will have a significant impact on the noise level, even with the same level of noise stimulus that is creating the noise. So the standard does break it down based on pipe sizes, and those are sizes classified as pipe size 1, 2, and 3, with pipe size 1 being those smaller than a 12-inch IPS, pipe size 2 being those between 12 and 26, and pipe size 3 being greater than 26 inches up to 40 inches. There is no standard that defines any testing or configuration methods for greater than a 40-inch IPS, but it is typically usually a Class 3 is adopted for those larger sizes, since there is nothing predefined for those. This is a summary of the performance characteristics that are required to rate your system as meeting the requirements of a given class and pipe size range. So you can see on the bottom or on the left side of this table the different classes available from A, B, C, and D, and then the different pipe size configurations within each. For a supplier to be able to claim that their system meets the performance requirements of, as an example, a Class B2 system, they must demonstrate that they meet the insertion loss as defined in this table for each of the different octave band center frequency levels that you can see. So at 1,000 hertz, you would need to demonstrate 15 decibel insertion loss. At 4,033 dB, it's not acceptable to say that you meet the performance at one frequency but not at another and still call the systems compliant or certified to the class that you're working with. So it's very important to understand when you are looking at rated or certified systems that you do fully understand what they were tested to and that they were tested to be fully in compliant with what the standard defines as being required. Within our JM product portfolio, we do have some predefined configurations that meet the requirements of the different classifications, going from our Class A3, B3 system in the bottom left, which is two 2-inch layers of mineral wool, 1 pound per square foot layer of mass-loaded vinyl, and then a 0.016 aluminum or greater, so it can be a thicker or higher mass metal on the outside, but it must be a minimum thickness and mass of that of an 0.016-inch aluminum. So that configuration will meet the acoustic requirements of a Class A3 or B3 system. So we tested to the largest pipe size configuration, which is the most difficult within the pipe size ranges. Our C3 system, which meets the requirements of an A3, B3, or C3, is similar, but adds a second layer of the 1 pound per square foot mass-loaded vinyl. You could substitute a single layer of 2 pound per square foot instead of 2 layers of 1 pound to simplify the installation if you wanted to. And then our D3 system on the bottom right, a little more complicated configuration, adds a 1 pound mass-loaded vinyl in between the first and second layers of the 2-inch mineral wool, as well as a third layer of mass-loaded vinyl between the outer layer of mineral wool and the metal jacketing. And then that configuration does meet the requirements of all 4 classes. And I will note also, or you can note on the chart, that with the C3 and D3 systems, we do upgrade to a 0.020 stainless steel to get the mass that's required for the performance levels, the insertion loss levels that the standard defines. When you are looking at the performance of different acoustic systems, it's important to keep several things in mind. As I mentioned earlier, all of our systems, all of our configurations were tested to the pipe size 3 requirement for each of the classes, which within each class is the most difficult to meet. If you take a look at the table, you can see that the insertion loss requirements for an A3, B3, or C3 or D3 is higher than that of at certain octave frequencies than it is for the A1 or the A2. So we did test all of our configurations to the most difficult requirement within each class. All of our configurations use only 3 materials, so 2-inch mineral wool, mass-loaded vinyl, and metal, all of which JM provides. So you can get your entire acoustic system from a single supplier, which makes sourcing everything that you need much, much simpler. And the Class D3, which is the most difficult of any of the acoustic configurations to meet, we do offer a configuration that meets that requirement. One other thing to keep in mind that's important to know is that a system that is tested and certified to meet the requirements of pipe size 2 cannot be upgraded and applied to the larger pipe sizes of the pipe size 3 range and be guaranteed or certified to meet the performance requirements of that larger pipe size. So if you do have large pipe sizes in the pipe size 3 category, you need to make sure that the supplier of the materials did test to that requirement to verify that the system is meeting the performance requirements. So that's kind of a quick overview of the acoustic requirements and capabilities of the mineral wool materials. So now let's move on and take a look at the V-groove portions of the mineral wool product family. I had touched on this a little bit at the beginning in the introduction when we were looking at the different configurations available. And this slide gives you a very good graphical representation of the big difference between molded or mandrel wound pipe insulation versus V-groove pipe insulation. On the left side, you see the molded or mandrel wound material. It does ship in the round format, so you have a limited amount of material in a box, whereas the equivalent V-groove material, since it ships flat, you can get a whole lot more material in the same or less packaging volume or packaging space or space on your warehouse floor. This is an excellent representation of visual representation of what that benefit means. The picture on the right-hand side shows you the material required to insulate the same length of the same pipe size for 2-inch thick insulation in 4 different configurations of material. The stack on the left, slightly yellowish or goldish in color, is calcium silicate. The second one from the left, the bluish color, is perlite. The furthest on the right is the mandrel mandrel wound or molded mineral wool, and then the one that's circled in yellow with the little bundle in black plastic wrap on the pallet. That is the exact same amount of material needed to cover the same amount of pipe, but in the V-groove, which ships flat. So you can see that you have a whole lot less volume needed, a whole lot less space needed. You're going to benefit from that in your warehouse space, so you can get more material in the same amount of warehouse space, or use less warehouse space and free it up for other materials that you may need. And then a big extension of that benefit of using less space also comes into play when you're looking at shipping costs for the materials. This is an example for a 12 by 2 configuration, so it's a 12-inch pipe, 2-inch thick insulation material. With the mandrel wound material, you can get just under 2,200 linear feet worth of insulation on a truck, whereas with the V-groove configuration, you can get almost 4,900 linear feet, so more than twice as much material on the same size truck. So big benefit there in terms of offering some cost reduction. And with that, I will turn things back over to Natalia, and she will talk with you about some exciting things you can do in terms of taking your mineral wool material to some next levels of performance.
Excellent. Thank you, Scott. All right. So we just heard about all the excellent properties of mineral wool and how can it be used throughout the facility. But like any type of insulation, mineral wool has its limitations. And this is where we would like to talk about the hybrid systems where we can use the benefits of different types of insulation to get you to the end goal and allow you to use the mineral wool more expensively at your facility. So one of the weaknesses of mineral wool, so to speak, is the binder burnout. So what is binder? Binder is an organic resin that is used in the processing, and this is what is used to hold the fibers together. It's really used for any type of fibrous insulations. It's not unique to the Manville 1200 from Johns Manville. It applies to mineral wool from other manufacturers as well as fiberglass. And due to time and temperature, what is going to start happening is that this organic material will start basically oxidizing and essentially decomposing. And as a result, you will have some negative effects. And we'll talk a little bit about that in the next slide. But here, what you could see on the figure on the right is the picture from the field. And you could see the darkening happening right around the pipe, and this is the evidence of stages of the binder burnout. You will see it's darkest closest to the pipe, and that makes sense because that's where the highest temperature is concentrated, and then it kind of gets a little bit lighter as it goes to the perimeter. The binder burnout can be kind of more in initial phases as a darker color like you see here, or it can go completely to the white color the longer the time spent or the higher the temperature. Also, this picture, I just want to point out for those of you who install insulation all the time, this is actually an example of how not to install the insulation because the joints are not staggered, but it is still nonetheless a good demonstration for the binder burnout. So again, what's the big deal with the binder burnout? Well, as we touched on, so what will happen is also you can lose the water repellency because none of the water repellency that is added on the market is stable all the way to the maximum use temperature. The second piece is that because the binder is used to hold the fibers together, this is what gives you the compressive resistance. Even though we can't really speak too much about the compressive resistance of mineral wool as compared to other types of insulation, especially rigid types, it still has, some firmness to it because it's a relatively dense insulation. So what we see here on the right is that as the mineral wool starts losing the compressive resistance, you may start seeing more of a damage, kind of structural damage. Some of it may be evidence like in here with the fish mouthing of the metal. Again, this figure is really demonstrating the fish mouthing effect. Typically, the seam will be installed at 6 o'clock degree, but even if you can think about it with a driving rain situation, if you had this kind of gap in your jacketing, even if originally it was sealed with mastic, which it should be really sealed with mastic, you can still drive that water into the mineral wool. And if you lost the water repellency, or at least partially, that could be a problem. So between the water and the loss of the compressive resistance, both of those will have actually negative effect on the thermal performance because obviously you will be talking about less of a thickness. And then the water is a great heat conductor, so you're going to be losing heat performance with that as well. So now that we understand kind of what's the big deal about this, what can we do about it? And we've done this study. I was actually for NACE for the conference, I guess in February, which unfortunately got canceled due to COVID. So I will be presenting some of the information that we gathered for that work. Mineral wool was used in the study, and Scott already covered so many great properties. I'm not going to touch on that, but I will introduce Insulate HT hydrophobic microporous blanket, which is used here. And why do we select it? Well, it's really our best thermal performance insulation within the standard industrial portfolio, other than the compression pack aerogel material. It comes in the blanket form, so you could have just one SKU on site. Because of the great thermal performance, you could get away with less of the thickness. So you can use it in more of a constrained spaces. It has a very low corrosive potential, and it also hydrophobic. So this is kind of advantages for it. One of the disadvantages is that it's more expensive than mineral wool. So with this study, what we've done, we evaluated 3 designs. So we were looking really within this work, looking at the system design aspect. So with the first design, we have just a standard traditional, you have a pipe, mineral wool, and then the jacketing. And the next 2 systems were with microporous blanket with Insulate HT installed either directly onto the pipe, so it was between the pipe and the mineral wool, so essentially a base layer. And then the second scenario, design C, it was installed over mineral wool, so as a kind of the last layer. And now we'll look at some of the visuals that we've got from this work. So the first, in a traditional design, we are observing the binder burnout, and you could see this as the ring. As I've mentioned, the binder is common for all fibrous insulations. Right now, it kind of looks more of charring. The conditions for this work and what we're looking at right now was exposed to 600 degrees Fahrenheit for 24 hours. So definitely an obvious binder burnout. The second design is, that's our design B, where we have Insulate HT microporous blanket as a base layer. This is kind of the shiny surfaces. It's a quilted blanket. And you can see some of the evidence of the binder burnout kind of right on the outside of, at the interface, I should say, but definitely less. And it makes sense because if we think about it, well, we put an insulation in between the pipe as well as the mineral wool. And so intuitively, it certainly makes sense. And the design C, what we have here is that we have the blanket over the mineral wool, essentially as the last layer. And we don't see the kind of the ring of the binder burnout, but you can see the overall color is darker. So we see some of this charring, so to speak, for lack of a better word, throughout the whole thickness. And again, it makes sense because we have the heat close from the pipe kind of gradually radiating into the outside. So what we can conclude here is that from the visual perspective, we certainly see less of the binder burnout when we have the Insulate HT as the base layer in design B. We also have done some quantitative work. So it was not just looking at the pictures and at the insulation. We've done some quantitative work, and we determined that not only visually we see less of the binder burnout, but having that Insulate HT microporous blanket protected and basically retain the water repellency of the mineral wool is the same as it was coming out of the box, at least at the conditions that we studied here. And what does it mean for the facility? Really, this concept of this work was, what does it mean if your insulation potentially can get wet, and how do you have this resilient system design? So this is where we would say that the hybrid system should be probably considered in many more situations than it currently is used. And one of the benefits in using the hybrid system with mineral wool would be that you can minimize the binder burnout, and as a result, minimize this, one of the, so to speak, mineral wool's weaknesses of losing the structural integrity. So you can maintain structural integrity of mineral wool as well as maintain the water repellency. So with that, let me give it back to Scott for conclusions.
Perfect. Thank you, Natalia. And again, excellent discussion about how folks can look at opportunities to use mineral wool in areas where they might not have previously considered it due to some of the limitations that you mentioned, that you described. So that kind of concludes most of the information we wanted to share with you. Just do a quick summary and take a look at some top-level takeaways from the material we've covered with you today. As you can see, JM does offer an extremely wide variety of different water repellent mineral wool products within our product portfolio. It is one of the broadest arrays of configurations available. So if you have optimized different application areas of your project and selected different configurations, you can once again still get them from one supplier. As Natalia has described, you can utilize a hybrid configuration to allow you to take advantage of some of the excellent benefits of the mineral wool system, whether it be low cost or water repellency, or maybe it's acoustic performance without having significant concerns about any loss of performance as a result of binder burnout or losing any of the water repellent capability. So ensuring that the mineral wool can continue to deliver the benefits it was designed for throughout the life of the installation. Talking specifically about acoustic systems, making sure that you're very careful to take a look at what your requirements are in terms of the insertion loss, identifying the relevant class of configuration you need, as well as the pipe size requirements, and then picking a material that truly is tested and certified to deliver the performance that you need. And then also considering the different options within the V-Groove family of mineral wool products, and looking at the advantages that this configuration can deliver to you, vast majority of which is in the cost area. V-Groove mineral wool is a lower cost than the molded material to begin with, and then also gives you the cost savings as far as storage space and freight, while still meeting all of the performance requirements of the ASTM standard C547. So the thermal performance is the same as that of the molded or mandrel wound material, but does give you some additional advantages that the mandrel wound can't deliver. So again, it's important to take a look at any specific or unique requirements that your job site or project may have, making sure that you're picking the right material. And then if you are picking mineral wool, again, taking a look at the different criteria that are important and the different priorities that you have within the project, and picking the optimal mineral wool configuration that's available as well. And with that, we will turn everything back over to Kim, and she will share with you some additional information about how you can get more information from Johns Manville.
All right, thank you so much, Scott. So I just want to go through a couple of additional resources that we have available, and these are they're basically designed to help you help you find more information about topics at hand. So the first one I want to talk about is our installation intel on the source. So today's webinar, as I said at the beginning of the presentation, we don't send out a copy of the webinar, but we will send out we will post it on live, and once it's online and once it's live online, we will send you a link to that so that you can watch it. But what that link will take you to is to the source. And on the source, we have webinars, ebooks, our latest blogs, technical documents that will be helpful, descriptions of our products, and then tools like the NEMA 3E Plus tool, or tools that are designed to help you identify which products are going to be ideal for your application. So if you have any interest in visiting the source and getting more information, and again, this is all educational, you can access it from the industrial portion of our homepage. So you go to johnsjm.com, click on installation, you'll see it right there at the top of the page, and that'll open a drop-down menu. Then you go to the industrial page. Once you're there, you can either click on Webinars on Demand, you should see that to the left side of your screen in that left menu, or you can click on the source, and that'll be on the right side of your screen in that right menu. The next thing I want to talk about is our technical support. So if you have any questions that maybe you think of a question at the end of the presentation, maybe you think of it later tonight, you can call us on this phone number and we will actually help you get to the bottom of it. Maybe you want help updating your specifications. We have people in place that are specifically designated to help you do that. And you can get that technical support through this number right here. Also, for the industrial business specifically, this is our technical support roster, and I recognize that it's a little bit hard to see there, but we have people designated for each territory, and Scott Sinclair, who's presented here today, his responsibility is to specifically support engineers throughout the country as they are trying to identify which products are best for the application and which products will meet the needs, particularly when they're coming up with new applications, new work, that sort of thing. So if you look at this list, you can find the people that you'll be working with based off of your region of the United States. And then we also have international people who are a team designated to support our international customers. So the next thing I wanted to talk about is our Engineer Advisory Council. And this is basically, we get together with a small group of engineers to talk about your pain points in the industry and how we as a manufacturer can help support you better. So if you are interested in participating in this, please let us know. You can answer the question in the survey. Obviously, the Engineer Advisory Council is not going to happen right now given the state of COVID. But once things start to ease up and we get past this, it's something we will pick up again. And so if you have any interest in participating in this, you can get a half-credit certificate, half-day credit certificate of completion. And so we definitely are always looking for new people with who are thought leaders in their businesses and industry who want to contribute in a goal to further evolve the market. And then finally, we have a certificate of completion, as I just mentioned. This will go out to you after the presentation. You should have it in your inbox by Friday, I believe. And with that, we're going to take it to questions. So Scott and Natalia, are you guys both ready?
Yes, ma'am.
Excellent. So we'll start with our first question, and that is your Manville 1200 industrial board FM approved? Scott, I'll send that to you first.
FM approval is not something that we typically see with as a requirement within the industrial product sector. So our industrial mineral wool portfolio does not specifically have FM ratings or FM approval. That's typically something we would see more in a commercial application, and we can definitely put you in touch with our folks on the commercial side of the business who deal with the mineral wool products that we offer into that market, and they could address that question for you more specifically.
All right, excellent. Natalia, I'm going to send the next question to you, and that is, hi there, I'm working with a specification that calls for mineral fiber meeting ASTM C547 Class 3. It appears that the class designations are no longer used in ASTM C547 and are now replaced by types and grades. Do you know when this change was made? And I'd also like to make sure we correlate the class designation to what the current standard is used.
Sure. This is a great question, a historical question, actually quite interesting. So yes, originally there were classes 1, 2, and 3, primarily devised by the temperature range. Class 3 is 1200 degrees as of the version of 1977. The change happened between 1977 and 2000. In order to help better answer this question, because we'll probably have to dig a little bit more and kind of find the best match for the current types and grades, I would recommend calling our technical line, and we can certainly dig into that. It's just a little bit past this discussion, but yeah, that's correct. It used to be classes, now it's grades and types.
All right, thank you. The next question is for you, Scott, and that is, what is the largest pipe diameter that would work for Manville 1200 pipe insulation? And the question further asks about the ISO 15665. So if you could touch on that a little bit again, that would be great.
Okay. The pipe size range capability within the mineral wool family differs depending on which type you're going to be using. Within the MANDREL wound or molded product, we'd go up to a 44-inch diameter pipe, and that would be in quad sections. Within the field formed, we actually can do a V-groove configuration that would take you up to a 72-inch pipe diameter. And so there is quite a wide range of capability. And then so the products within that would all apply within your ISO or your acoustic standard, though as I mentioned during the discussion, the standard really only covers up to 40-inch, and then beyond that, you'd need to rely on your engineering or your design group to do an engineering assessment and determine if they want to take the pipe size 3 configuration and apply it to the requirements for anything over that 40-inch diameter pipe size.
Thank you, Scott. And can you clarify the Manville 1200 pipe MANDREL wound versus V-grooved in regard to ISO 15665?
Both will give you the equivalent performance as long as you're using the 8-pound density in the V-groove product, which would match the 8-pound density of the molded material.
All right, and just to clarify, the V-grooved has not actually been tested to ISO 15665. Only the MANDREL wound has. So while both will offer acoustical performance, strictly speaking, the Manville 1200 pipe only has the MANDREL or the ISO 15665 testing. So the correct. Next question. Yep, the next question I have is for Natalia, and that is, do any of these products have IMO or U.S. Coast Guard certifications for use in the marine industry?
Yes, we do have products that I listed. So we do have IMO for our pipe MANDREL 1 pipe installation, well, U.S. Coast Guard. And U.S. Coast Guard follows the IMO FTP criteria, as well as our industrial marine board, as well as our A30, A60 marine board. And we have those certificates and we can put them.
Great, thank you, Natalia. The next question is for you again, Natalia, and that is, does the water repellent treatment impact the performance as an insulator?
I guess usually when we have this kind of question, I guess the concern is, would it impact? Probably negatively. So no negative really impact, because so this treatment is, and I also want to kind of clarify one of the pieces. While we do the testing on the surface, the water repellency is actually applied throughout the product. So if you were to cut it or anything, it's still water repellent. But going back to the question, with water repellent, no, I don't know why would it impact the thermal performance. If anything, it should be kind of better by minimizing potentially ingress of water, and water would be detrimental to performance, but by itself, I don't see why. Yeah, nope.
All right, thank you. Scott, this next one is for you, and that is, what is the definition of insertion loss?
In the insertion loss, the way it is defined within the ISO standard is you're actually testing the noise level surrounding a pipe with a noise source on the inside of the pipe. You get the sound pressure level at the different octave frequencies with no insulation, no treatment on the pipe. Then you apply your acoustic insulation system and you measure it again with the same noise source. And then insertion loss is very simply just the mathematical difference between the sound pressure level reading or the decibel reading with no treatment and the reading with a treatment, and that tells you how many dB reduction in noise that you get.
All right, thank you. I'm going to pose this next one to both of you. I'm not sure if we know the answer to this one, but it is there any standard to gauge the binder burnout on existing insulation, or any recommended methodology to examine binder burnout extent?
I'm not aware of such a thing.
No, either am I.
I think you could just unfortunately, open the system and visually probably observe. But theoretically, if your thickness really was not impacted, not theoretically, but in general, if you're not worried about your insulation sagging under the jacket, the binder burnout does not affect thermal performance. So the fact that it happens, you're still going to get your performance, as long as the thickness is not impacted.
All right, excellent. Scott, the next one for you is, what is an SKU?
That's basically it. They call it a SKU. It is basically just an individual configuration of the material. So if you're looking at say the MANDREL wound or molded pipe insulation, an individual SKU might be a 3-inch pipe size with 2-inch thick insulation, and then another SKU would be 2.5-inch thick, and another would be 3-inch thick, and another would be every other pipe size. So each individual pipe size insulation thickness combination could be a different SKU.
All right, thank you. Scott, I'll give the next one to you as well, and that is, for binder burnout, have you seen any evidence of insulation sag under the weight of the insulation or fiber shakedown due to pipe vibrations affecting the performance of the insulation material?
Normally, under applications where you don't have the vibration element, you would not see a structural breakdown of the material. The structure will be maintained, and the thermal performance of the material will be maintained, but you do have to address the concern of any vibration. If there is vibration, then the fibers that are left behind after the binder does burn out will be susceptible for being disturbed or displaced, and they would have a tendency to settle at the bottom, and eventually you could end up with your metal jacketing resting directly on the pipe at the top and all the fibers in a heap at the bottom.
All right, thank you, Scott. I do want to note that we are right at 1 o'clock. We do have a number of other questions to get through, so we will continue to answer questions up until 1:15. Any questions we don't get to today, we will we'll send out an answer to you directly in an email so that you can have your questions answered. So also, all the questions will be recorded today or answered, so you can either watch the recording or wait for the email to come through. So the next question is for you, Natalia, and that is, does JM still run its own testing in the Littleton and R&D Testing Center, or is it done elsewhere?
Yes, we still have our R&D Littleton Test Center. We do a lot of the testing here. If there's certain testing we cannot do, we'll go to the outside laboratories. We'll work with UL, Intratech, as well as other laboratories as needed.
All right, this is an interesting question. I don't know if any of you know it. Out of curiosity only, do you have any idea what the insulation of the structural steel was in the World Trade Centers?
I don't know.
I don't specifically know, but I would suspect it was probably more of some type of a spray on fire protection insulation, but no, I don't know specifically.
Yeah. All right. Natalia, this question is for you, and that is, does any chemical or anything else apart from high temperatures affect the water repellency of the mineral wool?
I'm thinking right now, not that we have found so far. I mean, there may be some unique situations that probably, if there's some concerns, I would recommend contacting our technical side. But yeah, it kind of would be case by case dependent. So far, we have not found such a situation.
And I guess one other important thing to point out, and I think you may have mentioned this earlier, Natalia, is that the water repellent feature in the mineral wool is not an additive to the general chemistry of the manufacturing of the mineral wool. It's actually part of the binder. So part of the chemistry of the binder includes compounds that give it the water repellent nature. So you're not as specifically worried about something that's just going to attack the water repellent feature. Whatever attacks the binder is going to impact the water repellency of the insulation.
Yep, good point. Mm-hmm.
All right, thank you both. The next question, let's start with Natalia, and then Scott, if you could add to it, that'd be great. And that is exactly what is in the binder burnout, and also if you use an adhesive in a V-groove, what is the burnout of it? And I think they're asking about the temperature at which the adhesive would burn out.
Well, I think what kind of makes me pause is exactly what is. So it almost sounds to me like the person is asking what is the composition of the kind of burn off when it occurs. I don't think we have that information. I mean, the binder burnout and decomposition happens at an elevated temperature. It's hard to really pinpoint. Certainly it would impact adhesive, but if the individual is looking for kind of the breakdown, I don't think I have that information. At least that's the way I guess I'm interpreting the question. Scott, what's your take on it?
Mm-hmm. Yeah, I'm not exactly sure by the question exactly what information they're looking for. It might be best if we have your contact information, we can reach out to you and clarify exactly what information you're looking for and see if we have an answer for you. Sure,
we can follow up. And additionally, anybody who would like to reach out to us afterward, you can certainly contact us at this phone number, and we would be happy to address any questions that you might have. So the next question, Scott, let's start with you, and that is, apart from ASTM and BS specifications, what other standards are acceptable?
That is going to really depend on several different factors relative to the project. Different owners depending on where they are headquartered and or where the project is being built, may adopt different standards, whether it be ASTM if it's a U.S.-based company or project, or a British standard if it's more of a European-based company and or project. There are ISO standards, which are international standards that can be applied that some companies will require conformance to, as well as you'll also have to look and see if there's any governmental or regulatory standards or requirements that would have to be met on top of more of the industry-specific standards. So there are others beyond ASTM and the BS British standards. There's the DIN standards, but it's really decided by the owners and or the engineering firm that's writing the specs for the project to define what standards have to be met.
All right, thank you. Scott, I'm actually going to give the next one to you as well, and that is to reduce ambient noise in a manufacturing environment, could I hang the wire mesh wrapped mineral wool product by itself, or is a covering required?
I don't see why the metal mesh blanket couldn't be hung. I don't know that we specifically have data in terms of the bond strength, so to speak, between the mesh and the insulation. So I don't know if you know anything about that, Natalia, if there'd be any concerns about the material separating over time if it was just hung by the mesh. The other thing that you would need to be concerned about is accumulation of dirt on the surface of the material over time. Dirt or contaminants over time could impact the acoustic performance of the material because it could close the open cell nature of the surface of the material and limit the amount of penetration that would be available for the sound energy to enter the product. You would also need to take that into account if you were looking at putting a facing on the insulation, because the facing could also impact the acoustic performance of the mineral wool material.
Yep, I agree. I think this is a good question for technical support. This is almost like in between, it's kind of beyond the industrial application, but there's some STC ratings we could look at. Usually adding facing will not help with acoustics just because it will aid in the reflective, kind of reflectance of the noise within the facility. But yeah, I agree. I think I would be a little bit concerned about the material getting not appealing over time and specifics about hang and support. So yeah, but it certainly could be used because mineral wool, like most of the fibrous insulation, is really great for acoustics control.
Yeah. And
all right, thank you both.
There are acoustic facing materials that specifically have, pretty much transparent to sound, to noise energy. So, you could definitely look at possibly facing it with an acoustic material and addressing the concerns that way.
Yep. And we do have those products in our more on the kind of BI side.
Yeah.
So, and some other kind of lines of business. Yeah, the technical service could be good in this one.
All right, thank you guys. So Natalia, the next one is for you, and that is historically the phenol-type binders were stated to not burn out until temperatures above 700 degrees Fahrenheit. In the presentation, the binder burnout stated that you start at temperatures above 400. Is this based on a different, not phenol-type binder, or is JM now stating that all binders burn out at greater than 400 degrees?
You know what, I don't have as much kind of a historical perspective, but you certainly will start seeing, and it's hard to determine a specific line, and that's one of the reasons why we had kind of more of a range, because you start seeing the basic decomposition slowly. Is essentially, if you think about any material, any organic material will start decomposing, at which point for each individual manufacturer. I don't think we went through that type of work to determine, so I don't think I can provide too much of the detail. And if we implied necessarily that this is the temperature when it starts decomposing, I don't think that was necessarily our intent. So I want to clarify that as well. But all binders will start decomposing. There may be some difference, slight difference, but not huge between manufacturers.
Yeah, there are different formulations of binders, each of which will start to oxidize at a different temperature. Most of the binders used in the mineral wool products available are somewhere in that 400 to 500 degree range. I also don't have the history to know if we ever promoted that it was 700, but it's definitely something we could look at. But we do know that with the binders we're using today for the Johns Manville mineral wool products, it occurs somewhere in that 400 to 450 degree range.
All right, thank you. The next question we have is, in process temperatures where binder burnout is not a factor, excuse me, what is the best way to preserve mineral wool water repellency against exterior water intrusion under typical cladding?
Well, no, go ahead, Natalia.
Well, I was going to start maybe with the point that, so if you're worried about the water coming in from the outside, any loss of water repellency or binder burnout will be happening where the temperature is. So when we size in insulation, one of the criteria oftentimes is used for the surface temperature to be less than 140 degrees Fahrenheit, safe to touch temperature, essentially. And so if that's the case, then at that temperature, your outer layers will be maintaining water repellency as long as that temperature is not exceeded. So even if you may be losing the water repellency at the core, your outer surface would be water repellent. So you will be protected from the intrusion, from the side of the cladding for the duration, basically, of your installation. Right. Scott, anything you want to add?
Well, if I understood the question correctly, I think the comment was that if you are going to be operating at temperatures below the binder burnout, what would you need to do to preserve the water repellency? If there is no oxidation or burnout of the binder, the mineral wool will retain its water repellency. So the key element then of the system becomes making sure you have completely appropriate installation of the jacketing system to minimize the opportunity for water to get into the system to begin with. The mineral wool is going to stay water repellent and help in that regard, but making sure you have a proper design for watersheds and things of that nature, and that penetrations are properly sealed so that there is no opportunity for the water to get past the metal jacketing.
All right, thank you. Scott, the next question is for you, and that is, what is the temperature use limit for Insulthin HT?
Insulthin HT is also rated for a maximum process temperature of 1,200 degrees Fahrenheit.
All right. The next question, and Natalia, I'll give this one to you. What is the best acoustical material?
That's an interesting question. Well, I think it depends on what kind of frequencies we're talking about and the specific situations. I mean, mineral wool, as we saw, it covers a wide range of the noise from high frequency to low frequency. So from the industrial portfolio, kind of traditional spectrum there, I would say that mineral wool is definitely a great material because the fibrous nature as well as kind of inherent density that is with it. But you still may need to include the mass-loaded vinyl layers. That's kind of all part of the system. I guess that's kind of how I look at it. Scott, anything
Scott,
from
would you
your
like
side?
to add anything?
Yeah, it really depends on what you mean by best performing. As Natalia said, it totally depends on on what your objective is, and if it's a low frequency issue, a mid frequency issue, a high frequency issue. At low frequencies, it's usually mass that's required to contain and limit the noise that's transmitted. At mid and upper frequencies, it's usually absorption that's required to reduce the sound transmission. So it really does depend on what you mean by best performance.
All right. Well, it is 1:15, and there are a number of questions we weren't able to get to today. So for everybody on the call, we will answer your questions privately offline. We hope you found the presentation useful today. Scott and Natalia, thank you very much for your time. And once again, you will be getting your certificates of completion, and those will be in your inbox by Friday this week. So we hope you guys have a great week, and we will be with you in the future with future webinars.
Great. Thank you, Kim. Thank you for joining us, everybody. Have a good day.
Thank you. Bye.